स्टूडेंट्स, आपका YouTube चैनल शंकर कोचिंग में स्वागत है। मैं प्रोफेसर प्रेम शंकर आज 11th क्लास के स्टूडेंट्स को NCERT बुक से चैप्टर नंबर 2 रिलेशन एंड फंक्शन पढ़ाऊंगा। आप इस वीडियो को अंत तक देखें। अगर आपको कोई डाउट हो तो कमेंट बॉक्स में लिखें। अगर आपको मेरा ये वीडियो पसंद आता है तो प्लीज़ इसको लाइक कीजिए, सब्सक्राइब कीजिए और अपने दोस्तों के साथ शेयर कीजिए। तो चलिए वीडियो स्टार्ट करते हैं। स्टार्ट द वीडियो। रिलेशन एंड फंक्शन, we will see the introduction, then Cartesian product, then relation and then function. In the introduction part, in the case of the suppose relation is there, so simple relation you can also take, like brother sister relation, then your this father and son relation, then you can take the teacher and student relation. Likewise in mathematics also we can take the relation, like two m and n lines parallel, then a is the subset of b, so these are known as a relation. Okay, now if you take the case of the function is also a special type of relation. If two sets are given, then we will take certain pairs, we will take, and that pair relate to this relation. For example, let's suppose I have two sets A and B. A and B is the two set, and let's suppose I take ordered pairs like this, A and B, A and B. So this A and B, this will be the this subset of your A cross B, A cross B. This is the A and B ordered pair is the subset of the A cross B, where this A is the member of your A and B is the member of your this set B. So this ordered pair is called the relation. Later on we will see that this function is the special type of relation. So this is our introduction. Now we see the Cartesian product. Cartesian product means suppose we have given one set P and another set Q. So P cross Q, it will be defined as P cross Q. This P cross Q, it will be defined as, this is your this P and Q. This is P and Q is the ordered pair, where this P is the member of P, set P, and this Q, this is the member of Q. And P and Q are the null set. But not P and Q are null set. If it will be the null set, it will be non-empty set, and if it will be the null set, then P cross Q will be infinite. If it will be the null set, either P or either Q, so this P cross Q, in that case it will be null set. Right. Now, when will we say that two ordered pairs are equal? Two ordered pairs are equal if this first element of the first one and the second element is equal to the second one. So that is called that the P and Q are equal. And let's suppose the number of these elements P, number of elements in P is equal to, in the P set, number of element P, and let number of elements inside Q is Q. Then what will be the number of set in this P cross Q? Suppose I want to find P cross Q and I want the number. So this is the number of element in P. Here is number of element in Q. P and Q. I want the number of element in the P cross Q. P cross Q, the number of element in P cross Q. So what is this value? So number of element in P cross Q, this is equal to your P and P into Q. So this is your number of elements. Let's suppose suppose P and Q set are given. In the case of this P, the sets number of elements are infinite. The infinite in that case, so what will happen? If you find the P cross Q, in that case also the P cross Q will be your infinite. This is also infinite. If P is infinite or Q is infinite, then your P cross Q, that will be also infinite. And lastly, let's suppose I want the A subset is given. I want the A cross A, that I want to find. So finding, let's suppose the value of this one is your ABC. ABC. The ABC is there, and what is there? ABC. This is the member of set A. If it is the member of set A, then what? Then this ABC is called. This ABC is called what? This ABC is called triplet. This will be called triplet. This is your triplet. I'm taking one simple example. I'm taking. Let's suppose P is given. Let's suppose the value of P is given here 2 and 3. Let's suppose it is given P is given 2 and 3. Let's suppose it is given 2 and 3. And let's suppose Q is given ABC. P is 2 and 3 and Q is ABC. And let's suppose I want to find P cross Q. So what is the value of P cross Q? P cross Q means Cartesian product of P and Q. So that will be how much? That will be simply your, this is 2A, then 2B, then 2C, and then 3A, then 3B, and then 3C. You can also see here how many elements are here. It is 2 elements, and here it is in the Q. How many elements are there? 3. So number of this elements will be P and Q. So 3 into 2, 6. So you can see here. This is the how many elements here? 6 elements are there in the Cartesian product of P and Q. Now we see the relation. Let's suppose I have two non-empty set A and B. This A and B is the non-empty set. Then the relation is defined as the A cross B, and this A cross B, this will be the subset of this Cartesian product. A cross B, this will be the subset of the Cartesian product A cross B. And if we take the ordered pair A and B, let's suppose AB is the ordered pair where A is the what? A is the first element and B is the second element. Then this second element, this is called what? This is called the image of this first element. This is the second element and this is the first element. Now if you take the first element, then the first element in the ordered pair and in the relation R from set A to set B, this is called what? This is called the domain. This will be the nothing but this will be the first element, all the first element, this will be called the domain. And if you take the second element, so this second element B, so this second element B, all the second element of the B, so that will that will call what? That will be called the range. This will be the range. And all the elements of this B, is called what? This will be the called codomain. This will be your codomain. This is codomain. Codomain. This is called the codomain. And you will find that this range. This range is what is that? The range is the subset of this codomain. This is your codomain. So this is about relation. From starting from this Cartesian product and taking the first element and the second element. Now I am taking a very simple example. Let's suppose I have one relation R. R is there, and that relation R. This is suppose you have given x and this is x and x plus 5. Let's suppose x and x plus 5 is given, where the values of this x is, let's suppose the values of x are the, let's suppose it is 0, 1, 2, 3, 4, 5, like this. Okay, and you have to find the domain and the range. How you find the domain and the range? So mind it, if you put the values here, so this will be what this is the first element, all this first element. So we will call this is what, this is nothing but this is your domain. This portion is your domain. And what about the range? So range, let's suppose I am taking this as a y is equal to your x plus 5. So if I put it the values, so I will get what? I will get the this value of y. This value of y I will get, if I put it 0 here, I will get 5, then 5, then 6, then 7, then 8, 9, and this is 10. So this is y is equal to x plus 5. So this is nothing but this is your range. So this is your range. Okay. So this easily you can find domain and the range. Let's see the function and types. First of all, we define what is the function. Suppose if a function from A to B is there, and this A B ordered pair, this is your this is member of function f. Let's suppose this is the member of the function f, and where this fa is equal to your b. Fa is equal to b, and the b is called the image. This b is called image. This is your image. B is called what? B is called the image of and this A is called what? Pre-image. This is the pre-image. So if I want to write function from A to B, so it will be denoted like this. F, this is function f. This is from A to B. So this is function. So if you see the types of function, there are many types of the function. I'm taking one by one. I have the functions like first one is the identity function. This is your identity function. The first one is. Second one is your constant function. This is the constant function. Third one is your polynomial. Identity, constant, polynomial. Then the rational function. Then we have the modulus function. Then signum function. And then last one is a greatest integer function. Greatest integer function. So these are the some functions type. I will explain one by one. Now we will see the function like identity function, then constant function, then polynomial function, rational function. So identity function defined as fx is equal to x. So if you will draw the graph of fx is equal to x, the graph is something like this. this will be the graph of fx is equal to x. Similarly, if fx is equal to some constant c will be there, so it will be the parallel to the x-axis. This will be the parallel to the x-axis. This will be parallel to the x-axis. Similarly, for the polynomial function, if I have any polynomial function, so in the case of the polynomial, the graph is something like this. This is the graph of the polynomial function. Polynomial function, this is your graph of the polynomial function. Whatever the polynomial we have to give in, this is the graph of the polynomial when the value is your x square. The function fx is here, this function fx is nothing but this is your x square. Now come to the rational function. In the rational function, if you draw the graph of the rational function, the graph is like this. This will be the graph of the rational function. This is the graph of the rational function. Here the values of this x is all the real number, but 0 will be not included. Why? If you put the value 0 here, you will get what? You will get the infinite. Modulus function. In the modulus function, it is defined for fx is equal to x when your x is greater than or equal to 0 and minus x when x is less than 0. So the graph for the modulus x, this will be like this. This is for the modulus x. X and minus x is there, so this is the symmetrical. Now the next one is your signum function. So for the signum function, it is defined as fx is equal to 1 for x is greater than 0. It is your 0 when this x is equal to 0, and it is minus 1 when x is less than 0. So for x is greater than 1, so this will be like this. And for x is equal to 0, it is 0. And for x is less than 0, it is minus 1. So this will be like this, minus 1. Now the next one is for the greatest integer. So for the greatest integer, the values are minus 1 in between your minus 1 and 0, and 0 for in between 0 and 1, and 1 in between 1 and 2, and 2 and 3. So the graph will be, this is 1 and 2. For this 2, this is 2 and 3. And then for 3, it is your 3 and 4. 3 and 4. Likewise here also, for 0 and minus 1, this will be, then for minus 2, it will be your minus 2, and this 2. Then for minus 3, at minus 3, it will be minus 3 and minus 2. So this is the graph for the greatest. Now we'll see the last topic, that is the real function and algebra. What is the real function? If the domain and range both is from the real number, then that is the real function. And if you see the algebra of the real function, that means algebras are addition, subtraction, multiplication, division, or we can say quotient or division. So we will define all this one by one. So first of all, I am taking the addition. First one is the addition. In the addition case, I have that function. Two functions are there. If f, that is one function, and it is defined in x to r, one function. And let's suppose another function g is there. G is the another function. It is your x to r is to r. If this is two function, and let's suppose this x x is the subset of this R, real number. X is the subset of R. Then for the addition case, we define it as like this: f plus g, and this x, this is your R. So this will be defined as f plus g into x, and this is equal to nothing but this will be simply fx plus gx. fx plus dx, where this x, small x, is the member of x. So this is about the addition. Now come to the next one, that is the subtraction. For the subtraction case. Subtraction case again, let's suppose I am taking this f, this is again x to r, then g again, this is your x to r, and the two real function, and your this capital X is subset of R. So how I define f minus g? This I define as a x. This is x denoted by R. So this I can write it by how f minus z into x. So this is equal to your fx minus gx, and where this small x is member of this capital X. So this is for addition and this is your subtraction. Only the difference is that this plus I had changed into minus, because this one is for the case of the subtraction. Now come to the next one, that is the multiplication. Come to the next, after that come to the multiplication. In the multiplication again this is f is your x, and this is x to r. Then the another function defined g, that is function g from x to r. Then this multiplication will be defined as fg and x, and this is equal to your fx into gx. So this is for the multiplication. For all x, this member of this subset x, this is the one, this set x from set x. So this is for the multiplication case. And the last one is the division, or you can say quotient case. Again, for the quotient case, again f and g, I am taking two real function. F is x to r, then function g, this is also from x to r, where this x is subset of r. So how to define this quotient? So quotient will be defined as a f by g into x, and that is equal to your how much? Fx by gx. This is your fx by gx, but this gx is not equal to 0, and this small x is the small x is the member of subset set x. So this is the algebra of. Thanks for watching. If you have any doubt, you write in the comment box. If you like my video, please like it, subscribe it and share with your friend. Thank you.